So let's take a look at the next example. X to the fourth minus 8x squared plus 6x minus 7 divided by x plus 1. So again, the first thing we want to remember is that we need to make sure the polynomial is in standard form, so highest power first, and that we have a placeholder for all our powers of x. So the first rule, we have x to the fourth, so we are in standard form because that's the highest power, but you'll notice there is no x to the third. So when I write my coefficients across the top here, I need to put a 0 in for that x to the third placeholder. So we'll come back to the divisor here, but I have 1x to the fourth, right? This was x to the fourth. And then for x to the third, I don't have anything in my polynomial, so I'm going to put a 0. Then for x squared, it was minus 8. For x, it was 6. And then the constant is negative 7. So the important part here is you need that 0 for the x to the third, even though it doesn't appear in your original polynomial. Okay, so I'm going to go off to the side. I'm going to take my divisor, x plus 1, set it equal to 0. Solve for x, so x equals negative 1. And that's the number that's going to come on the outside here in my box. So draw my line, leave a space for a second row. Remember, always bring down the first number. And now we are going to multiply the numbers on the bottom row. So negative 1 times 1 is negative 1. That goes in the middle. And then I'm going to add rows 1 and 2. So 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. Negative 8 plus 1 is negative 7. Negative 1 times negative 7 is 7. 6 plus 7 is 13. Then I have negative 13. My remainder ends up then being negative 20. Okay? So I now have the coefficients for my final answer, remembering that I started with x to the fourth, so that my final answer is going to be an x to the third. So this is x to the third minus x squared minus 7x plus 13. And you'll notice in this problem, I have a remainder. My remainder is going to be part of my divisor. So the way I write that into my final answer is, I'm going to say minus 20 over my divisor, which is x plus 1. So my final answer is x cubed minus x squared minus 7x plus 13 minus 20 over x plus 1. So hopefully you're starting to get a feel for the process of synthetic division. As you can see, it actually is not very many steps. You can get that final answer a lot easier than if you were doing long division. It's just a different process that you probably have not seen before, so it's just getting yourself familiar with how that process is. All right, let's take a look at one more example. 2x to the fourth plus 7x cubed plus 25 divided by x plus 2. So our divisor, x plus 2 equals 0, so x equals negative 2. My negative 2 is going to go out in my box here. And then I need to confirm my rules. Am I in standard form? In this case, I am, yes. Do I have all powers of x represented? Okay, in my original polynomial, I'm missing x squared and x to the first. So as I write those coefficients out, I need to remember to put in 0 as a placeholder. So I have 2, 7, 0, 0, and 25. Give myself a little bit of room here. My remainder is going to go there, and I'm going to bring down my 2. So now I just go through the process. I'm going to multiply. Negative 2 times 2, negative 4. 7 minus 4, 3. Negative 2 times 3, negative 6. 0 minus 6, negative 6. Negative 2 times negative 6 is 12. 0 plus 12 is 12. Negative 2 times 12 is negative 24. 25 minus 24 gives me my remainder of 1. So I'm going to look at my original polynomial. I started with x to the 4th. That means my final answer will be x to the 3rd as the starting power. So I'm just going to put in my variables back. So I have 2x to the 3rd plus 3x squared minus 6x plus 12. And then remember, I have my remainder, so 1 over x plus 2. Okay. So synthetic division, very, very helpful, very, very useful. You will see it when you start having to find multiplicity, when you need to start solving polynomials for zeros that can't be factored, and there's a lot of different uses for it, so you want to try to get comfortable with it and understand the steps and the process. One of the ways that we do use synthetic division is to determine if a binomial, so anything that's in the x minus a form, is a factor of a given polynomial. And you're still using the process of synthetic division, but what you're looking for is you want your remainder to be 0. So your remainder will be 0 if it is a factor. So the example I like to use is to ask students, is 7 a factor of 12? Most students can easily and quickly say, no, it's not, because when you do 12 divided by 7, you have a remainder. Well, that same process is true here. If I take a polynomial and divide it by a binomial, if I have a remainder, it is not a factor. And the flip of that is, if the remainder is 0, then that binomial is a factor of the polynomial. So let's take a look at an example. So I'm asking, is x plus 1 a factor of p of x equals x cubed plus 3x squared plus 3x plus 1? So I use the process of synthetic division as I did before. My divisor is x plus 1, so if I set that equal to 0, I'm going to get x equals negative 1 on the outside, and my coefficients are going to be 1, 3, 3, 1. So using the process of synthetic division that we just went over, I'm going to bring down the 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Then I get negative 2 up here. I get 1. Negative 1 times 1 is negative 1. And I end up with, because remember this last number is my remainder, I end up with a remainder equal to 0. So if the remainder is equal to 0, then I can say, yes, x plus 1 is a factor of the polynomial. All right, let's take a look at just one more example. Is x plus 3 a factor of x squared plus 9x squared plus 6x minus 1? So if I take x plus 3, set it equal to 0, I get negative 3 as my divisor, and then my coefficients, 1, 9, 6, and negative 1. I'm going to bring it down. We get 1, negative 3, 6, negative 18, negative 12, 36, and 35 as my remainder. So my remainder is not equal to 0, therefore I'm going to say no. X plus 3 is not a factor of x squared plus 9x squared plus 6x minus 1. So determining whether a binomial is a factor is just one of the uses for synthetic division. Like I said, you'll start to see it as we start solving polynomials, as we try to graph polynomials, looking for multiplicity. So if you're familiar with this, then you're pretty much set to go for all of those steps that come next. So hopefully this has either been a good introduction to synthetic division or a really helpful review for those who have seen it before. Feel free to go back and try the problems again. I will try to post some example problems in the document section on the website. Take a look at that. And if you have any questions, you can always feel free to email me for tutoring sessions or just any general questions. So have a great day, and I will see you soon.